So, I was going to write an in-depth blog post about using fibers in PHP 8.1. We were going to start with a basic example to explain them from the ground up. The idea was to send HTTP requests asynchronously and process them in parallel using fibers. But playing around with them, I learned that the RFC wasn't kidding when it said, quote, "The fiber API is not expected to be used directly in application level code," end quote. So instead of going down this path and making things way too complicated, we'll discuss what fibers are conceptually, why they are barely usable in application code, and how you can make use of async PHP after all. First, a little bit of theory. Imagine you want to send 3 HTTP requests and process their combined result. The synchronous way of doing so is by sending the first one, waiting for the response, then sending a second one, waiting, etc. This is what a synchronous execution flow is all about. Send, wait, process, repeat. In the world of parallel processing, we send the request but don't wait. We send the next, and only then wait for all requests. And while waiting, we periodically check whether one of our requests is already finished. And if that's the case, we can process it immediately. You can imagine how such an approach reduces execution time because we're using the waiting time more optimal. Now, fibers, they are a new mechanism that allow you to manage those parallel execution paths more efficiently. It was already possible by using generators and yield, but fibers are a significant improvement since they are specifically designed for this use case. You would create one fiber for each request and pass the fiber after the request is sent. And after you've created 3 fibers, you'd loop over them and resume them one by one. And by doing so, the fiber checks whether the request is already finished. If not, it pauses again, but otherwise it can process the response and eventually finish. In essence, fibers are a mechanism to start, pause, and resume the execution flow of an isolated part of your program. They are also called green threads, threads that actually live in the same process. And those threads aren't managed by the operating system, but rather by the runtime, the PHP runtime in this case. They are a cost-efficient way of managing some forms of parallel programming. But note how they don't add anything truly asynchronous. All fibers live in the same PHP process and only one can run at a time. It's the main process that loops over them and checks them while waiting, and that loop is often called the event loop. Now, the difficult part about parallelism isn't about how you loop over fibers or generators or whatever mechanism you want to use. It's about being able to start an operation, hand it over to an external service, and only check the result when you want to in a non-blocking way. See, in our example, we assumed that we could just send off a request and check its response later when we want to. But that isn't actually as easy as it sounds. And that's right, most of PHP's functions that deal with I/O don't have this non-blocking functionality built in. In fact, there's only a handful of functions that do, and using them is quite cumbersome. There is the example of sockets, which can be made non-blocking, but say we want to implement our example, sending HTTP requests. We could use a socket to do so, but we'd need to implement the HTTP protocol ourselves on top of it. Do you really want to be concerned with that kind of programming in your application code? The answer, for me at least, is no, which is exactly what the RFC warned for, and I'm not mad about that. Instead, we're encouraged to use one of the existing async frameworks, AMP or React PHP. With React PHP, for example, you could create an array of promises, each representing an HTTP request, and wait for all of them once they are sent. So that's a better example compared to manually creating sockets. And that's what the RFC means. Application developers shouldn't need to worry about fibers. It's an implementation detail for frameworks like AMP or React PHP. That brings us to the question though, what are the benefits of fibers compared to what we already could do with generators? Well, the RFC phrases it like so, and I quote, "Unlike stackless generators, each fiber has its own call stack, allowing them to be passed within deeply nested function calls. A function declaring an interruption point need not change its return type, unlike a function using yield, which must return a generator. Fibers can be suspended in any function call, including those called from within the PHP VM, such as functions provided to array map or methods called by for each on an iterator object." End quote. It's clear that fibers are a significant improvement both syntax-wise and in flexibility, but honestly they are nothing yet compared to, for example, Go with its Go routines. There's still lots of functionality missing for async PHP to become mainstream without the overhead of frameworks, and fibers are a good step in the right direction, but we're not there yet. So, there's that. There actually isn't much to say about fibers if you're not a maintainer of either AMP or React PHP, or maybe a smaller async PHP framework. And maybe even more frameworks or libraries will start incorporating them. Meanwhile though, there's also Swool, a PHP extension that actually modifies several core functions to be non-blocking. Now, Swool itself is a Chinese project and often not very well documented when it comes to English. But recently, Laravel announced first-party integration with it. And maybe this is the better strategy when it comes to moving PHP towards a more async model, to optionally integrate Swool or other extensions with frameworks like Laravel and Symfony. It will be interesting to see what the future will bring. Thank you for listening to this episode. If you enjoyed it, I would very much appreciate it if you left a like or review. You can share it with your friends and followers, and subscribe if you want to stay up to date about this podcast. I'm working on more. Thanks.